Welcome to Brain Vision.
In this problem, we are working with both magnetic field forces as well as forces due to electric fields. In this problem, we want to design a velocity selector. What this velocity selector does is it takes particles with a charge q is equal to 5e, e being the charge of a proton, and makes them move at a constant velocity, which we chose to be 8.75 kilometers per second. Now we chose a magnetic field we will use for this problem, being 0.55 teslas, and what we need to do is figure out what does the electric field have to be in order to make this device work. Now for this device to work, what we need is the force to be equal to 0 when the velocity hits 8.75 kilometers per second. Right, because once we have this, that means that the particles won't be accelerating anymore once they hit this velocity. Thus, they'll be moving at a constant velocity. So our net force here is going to be the magnetic field force, which is QV cross B, plus the force due to the electric field, which is Q times E. So this is what we want to be 0. And so what we could do here is just move, say, QE to one side. Right, so we get negative QE is equal to QV cross B. We could divide by our Q's, they just go away, and we could take the magnitude of both sides. And what we can end up with is that E is equal to the magnitude of the velocity times the magnitude of the magnetic field, and this, just plug it in the numbers, we get 4,812 volts per meter. So this is the electric field that we need in order to make this device work. Now, part B asks us, what direction do these vectors need to be in order to make this device work? So we know that the vectors are perpendicular to each other. So we can start off with just assuming that the electric field points upwards, right? Now the B field has to be perpendicular to it, so we just decide arbitrarily that it's pointing to the right. And now the velocity we know can point either out of the page or into the page. And we have to figure out which way does it point. To do this, we can look at the forces here, right? So the force due to the electric field, we know, points upwards. We know this because the charge of the particle is positive, right? So it points upwards. So what we need to do is we want to choose the velocity direction such that the force due to the magnetic field is going to point opposite of Fe. So we want to choose such that it points downwards. All right, so just using right-hand rule here with the equation FB is equal to QV cross B, what we end up finding out is that if V points into the page, that vector will point downwards, right? If you take your hands, point your fingers in the direction of V into the page, curl your fingers in the direction of the B field, your thumb points downwards, right? So this is the correct direction of our velocity. So this is the kind of setup that we need in order to make this velocity selector work. Part C in the problem asks, does this device work for other charges, right? So it has two parts to it, one part being for negative 5e and the second part being for any other positive charge. Now, as it turns out, this device will indeed work for any charged particle that you give towards it. So the answer to will this device work for any other charge is yes. Now, why is that? Well, if you look at our condition for this, right, which is F is equal to this net force here, our magnetic force plus force due to the electric field has to equal 0, right? This is the condition in order in order for our velocity selector to work, well, you see, we can just divide by q and get rid of it. And so it doesn't actually matter what our charge is because our net force will be 0 as long as we choose the right B field and E field. This will always go to 0.